So we're going to finish 4.4 today, and what we're going to be looking at are in systems of linear inequalities. We looked at some simple ones last time. We had a case where x was bigger than something, or actually no, x was smaller than something. I think x was smaller than 3, and y was greater than or equal to 2. And we would graph these, and we would get a solution is where we had an overlap. So just briefly to revisit. So we had something like this. Grab a pen. So for y greater than or equal to 2, we have something like this. And then for x less than 3, we have something like this. So the solution are where these two regions overlap. So that's the solution to the system of inequalities. Now, what we're going to do, clean this up a little bit. Just look at the actual solution itself. So if we just want to look at the solution, it's going to be this region. It'll continue on in this direction. It'll continue on in that direction. And finally, where we have a dotted line crossing a solid line, put an open point there. Because we cannot have anything on the dotted line needs to be excluded from our solution. And so where these intersect, well, a dotted line intersecting the solid line, well, you got a dotted line there at that intersection. That means that point can't be included in the solution. We got to kick it out. So this would be the solution to this system of equations. We're bigger than 2. We're less than 3. So that's what this region is. And then where the dotted line and the solid line intersect, make sure not to include that point. So any questions about that? So now we're going to look at something a little more complicated. There we go. So let's say we've got something like this. Well, again, what we want to do first, I recommend solving for y. And if we solve for y, we kind of see what will happen to our inequality signs, especially if we divide or multiply by a negative number. So for this equation, we could add y to both sides. subtract 1. And so we're going to get this inequality. Y is greater than x minus 1. So I'm just going to write that off to the side here. The next problem we're going to work on is this one. Next inequality. So again, I'm going to solve for y. Let's move the x over here, or move the x term. Divide by positive 3, and we're going to divide both sides by positive 3. Now, because it's positive 3, we're not going to flip around this inequality sign. It's going to stay the way it is. So we'll get and then what we'll end up doing is dividing each term by 3. And just as a reminder for this right here, we oftentimes write it like this. This kind of helps, well, in a sense, it adds more emphasis to 2/3 in front of x. Why do we do that? Well, this would be your m. If we're graphing this, which we will be doing, this would be your mx. So this is your m with a rise and a run. So let's take a look at these new versions of the system. New versions of the system inequalities. So y is greater than x minus 1. We have y greater than or equal to minus, I'm going to do the mx plus mx plus a b there. Switch the order on those. Same thing. They mean the same thing. I'm just switching the order. Instead of 4 minus 2/3 x, negative 2/3 x, also positive 4. All right. So what's happening here? Well, once we solve for y, the next thing we want to do is graph. So the first thing was solve for y. This was our number 1. Our number 2, we're going to graph. And we're going to graph these as if we have equal signs. And we also got to note, because there's no equal to on this, we're going to go with a dashed or dotted line. Because there's an equal to here, we're going to go with a solid line. So we're going to graph as if this is y equals x minus 1. So what we could do, this is our mx and our b, so b's minus 1. Our m is going to be 1, or 1 over 1. So we have our rise and we have our run. So we can rise 1, run 1, rise 1, run 1. We can keep going. So, and because this is I gotta be careful, because there's no equal to, use a dashed or dotted line. So that's graphing this one here. Now for this one, our b is going to be 4. Now if we take a look at m, negative 2/3 or negative 2 over 3. Again, we're going to put the negative on that top number. So this is going to be a fall of 2 and a run of 3. So starting at 4, we'll fall 2, we'll run 3. Just right about there. We'll fall 2, and we'll run 3 way out here. So that's going to be something like that. And you only need 2 points to draw the line anyway. You can do more points just to make sure your drawing is more accurate. I know I need to do that. But for a line, you need at most or at least 2 points. So solid, because we have the equal to. So let's take a look at this. That's our second step. For our third step, what we do, we have y greater than x minus 1. So that means we're going to shade all through here. We're going to shade above the line. And since we have y greater than or equal to, we're going to shade above this line. And where these intersect, where they overlap, that's going to be our solution. Now again here, dotted line, solid line, I'm going to put an open point there. So for the solution, the region is going to be here. This part's going to be our solution. Any questions about that? All right. So I'm going to do another one, except I'm going to use the idea of test points. I haven't talked much about test points. I only did one example with them. I'll do another one. Let's do this. Now, these are already solved for y. So we don't have to do anything as far as manipulating the inequalities. They're good to go. So we can jump directly to graphing. So taking a look at this one, our b is going to be -3. So we'll start there. Our slope is 2, or 2/1. So that means we rise 2 and we run 1. Rise 2, run 1, rise 2, run 1, rise 2, run 1, rise 2, run 1. And because we don't have an equal to, it's going to be a dotted line. A little more accurate. Now, for this inequality, our b is going to be +6. Now, for the m, it's -1 or -1/1. So that means we'll drop 1 as we run 1. Drop 1, run 1, drop 1, run 1, drop 1, run 1, drop 1, run 1. There we go. And again, because there's no equal to, again, dotted line. So we need to figure out, are we shading above or below these lines? Now, we can use the trick from before. If we have y greater than, that means we're going to shade above. Y less than means we're going to shade below. But let's say we're going to use the test point idea. Well, let's figure out test points for this. So what we want to do is pick a point not on that blue line, whether it's dashed or whether it's solid. It's not sitting on where this line is drawn. And I'd say go for an easy one. Let's go for that one. So the idea of test points is this. If the test point satisfies the inequality, then that's the side of the line you want to shade in. If it doesn't satisfy the inequality, though, you're going to shade the opposite side of the line. So let's test this. There's x, and there's y. That means is 0 greater than 2 times 0 minus 3? Is that in fact the case? Where now x is 0 and y is 0. Well, it turns out this statement is true. 0 is greater than -3. So because that's true, we're going to take either this side or this side. We're going to take this side. So now we got to work with this red line. So we got to pick a test point. And let's say, let's go with the test point 5, 5. Let's see what that does. So there's our x, there's our y. Now, if we plug these in, is 5 less than -5 plus 6? Is this in fact true? Well, simplifying, we get this kind of statement. 5 is smaller than 1. Well, 5 is not smaller than 1, no way. So this is false. So that means, since we picked 5, 5, we're thinking of this red line now. So that means we have this side of the red line or this side of the red line. Which one do we shade in? Well, 5, 5 is here on this side of the red line, and it didn't work. So what that means is automatically the other side is going to work. So this other side of the red line is where we need to shade. So let's see here. So now we need to determine our solution. We want to look for an overlap. Well, here there's nothing shaded at all, so no answer there. Here we only have the red. This little piece we only have the blue. But where we have overlap is in this area. And then where you have two dotted lines crossing, there's going to be no solution. So this will be the solution to the inequality. Now I should mention, if you have a dotted line and a solid line, you're going to have a hole. Dotted line and dotted line, you're going to have a hole. But if you have solid line and solid line, there won't be a hole. There you'll actually have a solid point. That point will be part of the solution. So let me do one like that, just to show you. Let's go with this. Let's make this more manageable to graph. So suppose we got something like this. Well, again, we want to solve for y in each of these inequalities. We're just switching the order. something like that. So I'm just going to put that off to the side, or in fact, what I can do is I'll just put it off to the side. Now we solve this. Or more y equals mx plus b looking like. And there we go. So these are the two lines we're going to graph. So starting with this first one. So we're going to graph these as if the inequalities aren't there, that these here are going to be equal signs. So that means we'll start with 1. And we have our m minus 1/2 or minus 1 over 2. So we'll fall 1, we'll run 2. So fall 1, run 2, fall 1, run 2. And because this is an equal to, we'll have a solid line. Now for this one, our b is 4. So we'll start at 4. Now we look at our slope. It's minus 2. Better make that an improper fraction. Minus 2 over 1. Again, keeping that minus on that numerator. This means we'll fall 2 when we run 1. Fall 2, run 1. Fall 2, run 1. 2, 1. 2, 1. And again, because of the equal to, again use a solid line. Now we take a look at these. The region for this one, well, since y is less than, that means we shade below. Now you could use test points also. Like you could use 0 and 0 here. You have 0 for y, 0 here. This will zero out. You'll get 1, a 0, works on this side. But since we have y less than, that means we shade below. Now we take a look at this one. Again, we have y less than. And you could use that same test point if you want to use test points. You could use 0 and 0. And again, you'll get the same, roughly same outcome. Y will be 0. When x is 0, this whole thing is 0. 0 plus 4 is 4. You'll get 4 greater than 0. That's correct. But we can just use the other observation. Y less than means we shade below. Oh dear, way beyond. Back up here. Can't go beyond the red line. Gotta stop at that red line. So let's take a look at our solution. Clean this up a little bit. Now the solution again is we want the overlap. Here, there's nothing at all. It's empty. So don't have to worry about that. Here we have the region for the red line only. Here it's only blue. But in this area, here everything overlaps. Corner here. And in this case, though, since we have two solid lines, that corner point will be included in the solution where the lines intersect. So any questions about that? All right. So the last kind of problem I want to do for this section, and I'll pull an example from the text. Well, there's a couple examples, but two more I want to do. Let's say we have this. So these are very similar looking. I mean, except for the numbers here and then the types of inequalities, they're basically the same line. Well, close to. So this is what's going to happen, though. The key thing is going to be the slope. So again, we're going to solve for y. So we've got that one. I'll write that off to the side. A bit more in an mx plus b form. So we have this. So again, we're going to graph this. And then when we do, well, let's take a look at this one. Our B is going to be 2. So we'll start at 2. Our M, negative 2/3, or negative 2/3. So this means we're going to drop 2, we're going to run 3. So we drop 2, run 3. And because this is a solid, I'm sorry, this is the solid line. That's going to be the line we're going to work with. Now let's take a look at this. Here B is equal to 0. You could think of it as a plus B, like that. So that means we're going to have a y-intercept of 0. If you want, you could plug in x is 0, y is 0, and again, pretending this is an equal sign, and it'll work. You'll get 0 equals 0. So we're going to start there. Ooh. Now, key thing though, same slopes. So these are parallel lines. Now, parallel does not mean that we don't get a solution. We could very well get a solution out of this. For example, shade above this line, we'll shade above that line kind of thing. I'll show you what I mean. Again, negative 2/3. It's really negative 2/3. So we're going to drop 2, and we're going to run 3. Drop 2, run 3. I'm sure my illustrating powers might not quite capture the parallel nature of these lines, but this is what we've got. So when I talk about there being a solution, why am I being a little questionable about this? I didn't do this to the other examples. Well, there's no reason to be concerned. Here, if the solution for this blue line is up here, and the solution for the red line is also up here, well, we're going to get overlap over here. So things are fine. Now let's take a look at these solutions. For the blue line, y is greater than. So we're going to shade above. Now, this is where things get curious. If this was also y greater than, we would also shade above. But it's y less than. So for y less than, we're going to be in the area below the line. Here's the deal. Where's the overlap? Well, here there's nothing. Nothing in there. And we have a blue area, we have a red area, but there's no overlap. So what that means for this system, no overlap means no solution. So that's going to be our answer for this kind of situation. Now this comes up with parallel lines because if you have lines with different slopes, somewhere they're going to intersect. It might be far, far away from the origin, but if you have lines with different slopes, they're going to intersect someplace. Where you don't get any kind of intersection is parallel lines. And now we got to be careful. If we have this kind of situation, we might not get a solution. So that is a possibility. Let's see. All right. So let me do one more example, a slightly more complicated one. Let's see here. Looking. Pulling something from the homework assignment. Groups. Oh. So we might not have 2 inequalities. We could have 3. We could have 4. So we have more than 2. The key thing we're going to look for, the solution we want is where all 3 regions are going to overlap. If we have 4 inequalities, we want the area where all 4 of the inequalities will be overlapping. So let me do an example with 3. So again, you want to solve for y, or when you just have x, solve for x. So we're going to get this right here. So we can rewrite the system of equations. So y is greater or equal to x minus 2. Then we had x is greater than or equal to negative 2. And y, keep wanting to do that as x, y is less than or equal to 3. So in this case, as we graph, So again, we're going to treat these like they're equal signs. So y greater than x minus 2? Well, b is our minus 2. Our slope is 1. Again, make it an improper fraction since it's not already a fraction. 1 over 1. So rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Again, it'll be a solid line because of the equal sign. Now, for x here, x greater than or equal to negative 2, we would treat this like it was x equals negative 2. And since we have a greater than, a solid line. And then finally, y less than or equal to 3. Let me see, I think I have a green pin here. Hold on 1 second. Dig that up. Yes, I do. So y less than or equal to 3, we're going to treat it like it's y equals 3. Just to put everything in here. We treated this as y equals x minus 2. Now let's stem this so we get the intersection. So now we got to shape things in. Well, for this line, it's y greater than. So that means we're going to shade above. Now, this is x greater than or equal to negative 2. Greater than negative 2, larger values are to the right. So we're going to shade like this. Finally, y less than or equal to 3. Let's see, maybe we can shade this kind of at an angle. Whew, that's a lot of noise. So here's the thing. We want points that satisfy all 3 inequalities. Make sure you can see that. All 3 inequalities at the same time. So we want points that will satisfy these at the same time. So there's a point that satisfies this one, that also satisfies this one, and that same point also satisfies this one. So how do we identify those incredible points? Well, those points will be the points where all 3 regions overlap. we want to look for all three of these solutions or regions overlap. So let's see. Well, here we have blue, we have green, but that's it. Over here, we have red and green, but that's it. Here we have red and blue, and that's it. So it looks like, though, we have blue, red, and green. Hard to see there. In this middle triangle. This triangle in the middle. So this here is going to be our solution. So right here, that's going to be our solution. So if we have three inequalities, our solution will be the region where all three inequalities overlap. If we have four inequalities, the solution will be the region where all four overlap. Where only two overlap, that's not a solution. That means we left one of the inequalities out. So going back to this one, three inequalities, we need the region where three inequalities overlap, or the solutions overlap. Whenever we only have two, that means one of the inequalities is left out, and that's not good enough. Our system requires three inequalities. There are three conditions we need to meet. We can't cheat and skip out on one of those conditions. Just not how things are going to work. You can sort of think of it like this. Let's see. To drive your car, you need a car. It has to have gas, and you got to have a seatbelt. Okay, maybe this one mechanically is not the case, but you want to have your seatbelt. You don't want to get hurt in it, more so than necessary in an accident. So before you're going to drive in your car, you need the car, you need the gas, you need the seatbelt. So, or if you want to prefer to do it maybe a little more mechanically so, let's say we assume you have the seatbelt. You have to have the car, you have to have gas, and if you're driving at night, your headlights have to work. We'll assume that you're safety conscious and you have the seatbelt. Car, gas, headlights work. If any of these three are missing, you're not going to be able to drive at night. It's not going to work. And let's say this is a complicated driving task. Won't be able to just to get by using street lights or anything. So same thing with this. You have to have all three. That means the only solution is where all three overlap. Just getting two doesn't count. Questions about that? All right. Let me see, is there anything else we can do? Because that pretty much covers that section. Anything else? I think that's it. So I did mention that we would be finishing a little early today. So just to give you an update on the plan, what we're going to do, we're done with Chapter 4. So now we got to start talking about Chapter 3 and Chapter 4 exam. So I'll do a review on probably Thursday. I'll do a review on Thursday. We'll start chapter 5 on Tuesday, and I'll probably do at least the first 2 sections of chapter 5, sort of watching the schedule. I want to make sure that we're going to be on track to finish on time. Chapter 5 is kind of a long chapter. We're getting into factoring, and we're going to kind of go over a lot of terminology. It'd be nice to get into chapter 5 right now, but I think if we started it now, I don't want to do the lectures that way. We try to keep these kind of packed together with chapter 5. Don't want to be having the vocabulary and then jump into chapter 5 the next lecture, and it's maybe a little too new for us to remember everything from before. So we'll do chapter 5, and starting next week, we'll probably at least get through the first 2 sections. I'll open the test for the weekend, and then we'll just move on from there. We'll get into chapter 6, and chapter 6 and chapter 7, it's going to get a little packed. So what I might even consider doing is posting some lectures if we need to, and I might do this a couple times. Post them up sort of like on the weekend or something, just to make sure we're staying caught up and we're not rushing too much towards the end. So that's going to be it for today. We're going to finish about 10, 11 minutes early. Usually don't do this, but I think it's a good place to stop. I don't want to try to jump into chapter 5 terminology and then cut that off from the lecture we're going to be doing on Tuesday. I want to put all that together. So that's it. If any questions, let me know. I'll post this as soon as I can, and have a wonderful weekend.